Hello friends, today in this lecture we are going to learn about ARDL co-integration. ARDL means auto-regressive distributive lag. So before starting the lecture, let me tell you what do you mean by term lag. Now first of all, let me tell you there are different types of lags in the time series model. So first type of lag is known as auto-regressive. So that means auto-regressive means auto means on its own. That means when the variable is depending on its own past, we name it as auto-regressive. That's why it's written lag of the dependent variable yt is depending on yt minus 1, yt minus 2 and yt minus 3. Okay, let's take an example. Suppose these are the different moves. And I can say that yt is a dependent variable. I want to predict or I want to see what will be my happiness in today's state, whether I am happy or I am sad. So I am going to see whether I am happy in today's state or not. So there can be various factors on which my today's happiness is dependent. So my today's happiness is yt. This is my today's happiness, that whether I am happy today or not and on what factors my today's happiness is depending. So I can say that my today's happiness is depending on my yesterday's happiness, or it depends on day before yesterday's sadness, or maybe something has happened 3 days back, or maybe something has happened 4 days back, or my today's happiness is depending on something which happens on 5 days back. Let's say we take the example that I gave the university exam and I topped in my university exam 5 days back. So the result was declared 5 days back and I was happy that I topped the university exam. So let's say today I am thinking about that. So today's happiness is depending on my happiness which was 5 days back. So that means my today's happiness is depending on my own happiness which has happened on my own event which has happened 5 days back. So that is known as auto-regressive. That means today's variable yt is depending on its previous variable. That means whatever has happened with the same variable in the past. That is known as auto-regressive. Second is distributive lag. Distributive lag means lag of explanatory variable xt. That means there are some other variables also on which my happiness is depending. I'm not saying now that my happiness is depending on my own past. It can be some other variable also by which my happiness is depending. So let's say this is my second variable, or I can say this is my dependent variable, and explanatory variable means independent variable. Okay, let's take an example over here. Let's say my kids are there and they gave the university exam and they stood first in their university exam. So this is xt. That means whether they have given the university exam and today's day result is declared in today's day. Result is declared 1 day back. Result is declared 2 days back. Result is declared 3 days back. Or result is declared 4 days back. So it can also happen that my today's happiness can depend on whatever has happened with me in the past, or it is also dependent on some explanatory variable. That means my kid stood first in the university exam, so I am happy because my kid stood first in the university exam and the result is declared in today's day. Or it can happen that the result is declared in yesterday's date and I am happy today after thinking that my kid is first in the university. Or maybe the result is declared 4 days back and I am happy in today's date because I am thinking that 4 days back my kid gave the exam and he or she topped the university exam. So that means my today's happiness can depend on my own past, or it can depend on some other variable, other explanatory variable, and whatever has happened with that explanatory variable in the past, it can also depend on that. So if it is depending on my own past, I will name it as auto-regressive. If it is depending on some explanatory variable that I have included in the model, that is known as distributive. And if it is dependent on the explanatory variable past, that means something has happened in the past with the explanatory variable which is affecting my dependent variable, we name it as distributive lag. And third is moving average, which we commonly known as error term. That means there can be, whenever we are creating the model, there can be some variables which we have not mentioned in my model. Okay, maybe in this example I can say that my today's happiness depends on some hidden variables that are not mentioned over here. Maybe there is something happened with my friend which I have not taken as an explanatory variable. So et minus 1, et minus 2, et minus 3, that means something has happened with those variables which are missing over there in our model. Maybe in today's date or maybe in the past, we name it as a moving average. So moving average means whenever your unexplanatory variable which is not being mentioned in the time series model and my today's happiness, my today's dependent variable is depending on that, we name it as that a moving average lag. So now let's come to the autoregressive distributive lag model. So autoregressive distributive lag is an OLS model, that means ordinary least square, consisting of lags of dependent variable. That means now we are taking lags of dependent variable y and explanatory variable x only. In the previous slide we have learned that there are three types of lags: autoregressive, distributive and moving average. So in autoregressive distributive lag model, we are not taking the lag of moving average, we are just taking the lag of itself and the explanatory variable. So ARDL model, commonly known as P and Q, is an OLS model consisting of P means lag of y. That means whenever we are writing P, we will be writing the lag, that means on which term, maybe 1 day back, maybe 2 days back of its own, and Q means lag of x. That means how many previous terms we have to see, so that we can say that y is dependent on the independent variable of previous day or day before yesterday or 3 days before 3 days before. So we name it as ARDL P and Q. So now we can write it over here, my equation yt, that means my dependent variable in today's state can be depending on its own past, that means 1 day back, its own past which happened 2 days back, its own past which has happened 3 days back, and so on till t minus p. Or it can also be possibility that depending variable can depend on explanatory variable which has happened in today's state, explanatory variable which has happened in t minus 1 day, t minus 2 day, or t minus 4 day, or t minus q day. So we can also write it in the compact form like this: ARDL model PQ, that means yt, dependent variable in today's state is depending on the dependent variable of previous lag, that means starting from 1 till p, and it also depends on some explanatory variable which is starting from 0 till q. You have to remember 0. That means it can depend on explanatory variable in today's date also. So now let's see what are the preconditions of ARDL model. So before using the ARDL model, there are some preconditions that you have to satisfy. Now first thing is that ARDL model will work on stationary as well as non-stationary data. So you don't have to worry that we have to first convert the data into stationary and then we have to do it. It works on both. Maybe it's that your data can be stationary or maybe your data is non-stationary. So if your data is non-stationary, we don't have to convert it. Second precondition is ARDL model can be specified for a combination of variable with I1. That means whenever you are seeing your variables, it should be a combination of integrated at first difference and it should be integrated at level. That means whenever you are saying that you are taking 2 or 3 variables, so you have to check all the variables whether their stationarity is at level or is at first difference. We are not saying that you have to convert it, you have to just check it whether all the variables are stationary at level or they are stationary at first difference. But we do not have to check whether they are stationary at second difference or higher. So if the variables are stationary at first difference or the variables are stationary at level, that means if we are getting the combination of these two, we will apply ARDL model. ARDL model can also be specified if all the variables are of order I1. That means if you find that all the variables are integrated at first difference, then also we can apply the ARDL model. Now let's come to the steps for ARDL model. So the first step is to check the stationarity of data. That means you just have to check whether your data is stationary at level, whether your data is stationary at first difference, whether your data is stationary at second difference. You don't have to convert it, you just have to check it. Second is you have to determine the optimum lag structure. That means because ARDL model means autoregressive distributive lag, that means today's value of dependent variable is depending on its own past. So we have to calculate that past, whether it is depending on 1 day back, 2 day back, 3 days back. So what is the lag? What is the period on which my today's variable is depending? And on its own or maybe of the distributed. So lag is important. So we have to first of all determine the optimum lag structure. Third step is you have to apply the ARDL model. Once you have applied the ARDL model, next step is you have to apply ARDL bond test. Fifth step is after applying ARDL bond test, you have to apply the vector error correction model, which is commonly known as VECM. Once you have applied or you have done all these 5 steps, the last step is the diagnostic check. So you have to do the serial correlation, that means both ARDL in short run and VECM, and model stability you have to check, that means again for both ARDL short run and VECM. So that's all for today's lecture. In the next lecture, we are going to learn how we are going to solve ARDL model in our studio. Thank you.